All right, let's look at the homework 5.6, problem number 4. All right, so we want to use the midpoint rule, and I'm going to actually use the GeoGebra instead of the program introduced here. All right, and we want to approximate it, this integral here, correct to within 0.01. All right, so let's open up GeoGebra here. All right, so first I'm going to type in the function. So the function is f of x is equal to, square root, so sqrt, and the parentheses, x plus 9, right? And hit enter, right? So you can see that actually you cannot see right now. Here's the function, right? Then I'm going to define a lower bound, which is 3. So I'm going to just a equals 3. And then b equals 7, right? And n equals, I'm going to just start with 1, right? Then we're going to have delta x, right? So here, delta x, the definition of delta x is simply b minus a divided by n, right? So we have that. All right, so I want to use the a, b, and n to define delta x, because that way if I change the, for example, n value to 2, delta value is automatically changed, right? So, but anyway, I'm going to go back to n equals 1. All right, so we have that. Then we want to use the midpoint, all right? So we're going to use a midpoint m, right, is equal to, all right, I'm going to use a left sum, right? Then we have to do a little bit of tweaking. So what you do is you have to shift the function to the left by a half of delta. So we're going to put the x plus, right, delta x. So we have delta x and divide by 2, right? Then start value is, of course, a, ending value is b, and the number of rectangle is n, right? So we have that. Right, GeoGebra even shows you the approximating rectangle here. All right. All right. So what we're going to do is we're gonna try to find the actual area. So what you're gonna do is a is equal to integral. All right. So it's going to be just an integral. Right, and the function is f. And start from A and end up B, right? Then hit enter. All right, hopefully. All right, so we can see that, so those are the actual values, right? So we want the approximation to be within 0.01. So I think I'm gonna change the rounding to say 3 decimal places. All right, so we have that. All right. So here, right? So this is the actual area. A is the actual area, right? Then here, M is the midpoint rule, and in this case, we're using only 1. It's actually a pretty good approximation already. All right. So, but the difference is slightly bigger than 0.01 in this case. So we need a little bit larger n. So I'm going to try 2, right? Then you can see that here, so this is the midpoint approximation, M, and A is the actual area. So the difference is within 0.01 already, right? So the answer to that would be N is actually big enough. 2 is big enough. So let's try 2. All right, then using that 2, and the value we got was 14.957, so it's going to be 14.96, right? So let's type it in. We got 14.96, right? Let's check the answer. All right, submit for testing. All right, I came back and looks like we got both parts correctly. All right, that's it. I hope that this was clear.